Yeah, thank you. Thank you for the invitation. I really enjoyed so far all of the talks and presentations. So my research is in the domains of social robotics and human robot interaction. So what I'm trying to do in the next 10 minutes is just to mention a few thoughts and reflections with regards to embodiment, of course. So what are social robots? So social robots don't have to be humanoid. They can have basically any shape. They can be animal-like or machine-like, but they engage people in an interpersonal manner. So they communicate and coordinate their behavior with people using a variety of means. This could be verbal, non-verbal. Non-verbal could be gestures, for example. It could be body movements. It could be tactile interactions or affective modalities. So using, for example, emotional expressions in the body movements or in the faces. So these robots, as I just explained, social robots, they definitely interact with people, not just with the environment, but in particular with people. So how is this related to embodiment, which then leads me to the question, who or what is embodied? So for example, if you look at these pictures here, would you say that the bears on the right are embodied, that the salmon that they are feeding on are embodied? But what about the bird in the background on the right? What about the rocks? What about the trees? Would you call them embodied? Now, when you look at structural coupling between agents and environments, this is actually a very interesting concept. So this goes back to research by Maturana and Varela, biologists and philosophers, who were wondering and publishing on the biology of cognition. And they very much proposed this concept of structural coupling. And so previously with my collaborators, I've been wondering how could we actually define then the structural coupling and therefore the embodiment of a system. So this was an attempt that we tried to make where we focused on perturbatory channels between a system X and an environment E, where you consider at a particular point in time how much the system can perturb the environment and how much the environment can perturb the system. And this could potentially actually also be made measurable. And this concept could apply to various types of systems, even software systems, even inanimate systems like chairs or toasters, in addition to all living organisms, of course. It can also be applied to objects like, Amazon smart speakers, which don't look anything like any living object, but clearly they also have perturbatory channels in the sense of how they can interact with the environment and how the environment can change their states. So I would, according to this reasoning, we can propose that all bodies are embodied, but some bodies are more embodied than others. So the nature and extent of embodiment has, of course, a big impact on the capabilities of the systems. For example, how a robot can interact with a person. And some ways in how to consider the nature of these perturbatory channels are perturbatory bandwidth and structural variability. So perturbatory bandwidth is the way how the system and the environment can influence each other. So you see here at the bottom my simple attempt. So you have the environment which can have various influences. The same for the system, like the social robot X on the right. But the interesting aspects are these mutual perturbatory channels, where the system and the environment can influence each other and can have an impact on each other. The other concept, structural variability, is more the scope for structural variation triggered through perturbation. So a system that can, through this interaction, both the environment and the system could adapt, they could learn, they could change their internal structures as a consequence of the structural coupling. And that, of course, I mean, many people have also highlighted that biological bodies are just so extremely flexible. In stick insects, for example, that have been studied extensively, if they lose a leg, you know, they don't despair. They can easily just continue walking. Although their walking pattern, of course, the coordination between the legs will change, but they have this immense flexibility to adapt to these circumstances. So the nice thing about really looking at embodiment from the point of view of structural coupling is that it's inclusive of, as I said, all kinds of living systems, animals, plants, but also robots. So these are some of the robots in my lab. And as we know, robots come in different shapes and sizes. They afford different types of social interactions, ranging from humanoids, which are very much inspired by human-human interaction, to more animal-like robots, or robots that have a more futuristic appearance. And this then leads me to this notion of social embodiment, which has been proposed and is quite relevant here, where the notion of social embodiment focuses very much on how postures, arm movements, facial expressions, and so on, how they arise when a robot or a person interacts with another person, and how they can lead to social interactions between the two. So my final comments are a little bit about applications, because I'm myself quite interested in applications of social robots in therapy, in education, also in care, for example, home assistance. So here we need to very carefully not only consider the embodiment in the sense of how the robot interacts with the environment, its senses, its actuators, and so on, but also how people perceive the embodiment. So this was a robot, for example, we designed for children, where we had to, of course, you know, very carefully choose how it can perceive the environment, how it can act upon the environment, inspired by various sources from the animal literature, for example. And we also had to consider to personalize the embodiment, so that, for example, children who were the primary target audience here, that they could also change the appearance of the robot in order to give them the impression that they have ownership about it. So just in case you're wondering what this robot actually did, here in Canada, basketball is very popular. And if you have children sitting in a wheelchair with upper limb disabilities, they wouldn't be able to pick up and throw a ball. So we designed this robot so that they could actually, through the robot that they control, they can play with balls. But also I mentioned affective expressions. They can be very important for the structural coupling in a social context of the robot and a person, with regards to the perturbatory bandwidth. So how can the robot influence the person? How can a person in return also influence the robot? So here we used a commercially available robot, the Miro robot at the bottom, and we designed facial expressions, we designed affective expressions for that robot in terms of movements of its head and eyes and the tail and the general body movements, the speech, and so on. And we took inspirations from a variety of literature in, for example, how animals and people express emotions and affect. We also took some inspirations from cartoon characters here. So here you can see an example how these affective expressions were designed based on examples in, for example, rabbits, in horses, in dogs, and so on. So we did a study also on how people perceive it, and are people actually able to recognize these emotions, and the results were very positive here. So the question for me is usually not what is embodied and what is not embodied, but how embodied is a system, and how would the system use the body. So, but the question remains, you know, what do we emphasize in our research? Is it about the structural coupling, or is it the emphasis on actually having a physical body? Now, finally, we also need to consider the more wider perspective. The embodiment is not only important for the social robot itself, how it interacts with the environment, how it interacts with people, how it might interact with other social robots. We also need to consider, in applications in particular, who else has a say in judging the embodiment of the robots. If you, for example, develop a system that should work as a companion in a care home or an assistant for nurses or doctors in a hospital, you need to consider not only the people who would directly interact with the robot, but also the managers, the people who are making decisions, for example, on how the system should be used. You need to consider the opinions of technical support staff on the robot's embodiment, on how the robot looks like, how it behaves. And of course, those people have different criteria. So for managers and department heads, for example, it's more about cost effectiveness. For technical support staff, it would be more about maintenance. So we need to really also consider, when we want to deploy those robots in applications, how cost effective it is, how easily can it be maintained, what other stakeholders, not only the people who directly interact with the robot, how do they judge the embodiment? How can we make it cost effective? Who would be able to fund those robots, or will they always just remain luxury items? We also, as a final remark, we need to be very careful with the embodiment, so how the robot looks like, what it does, how it interacts, not to reinforce stereotypes. We need more, so I would plead for having more creative imagination also in how robots could be designed in order not to reinforce stereotypes. So if you build a nursing robot, then I would very much appreciate not to build it in the shape of a female robot, but to be a little bit more inclusive and imaginative in this context. Okay, that's all I wanted to say. Thank you.